Hey guys, it's been a little bit since I uploaded that last video, like, I don't know, 3 days. Uh, been busy. If you don't know, I'm doing a Christmas light display at the library instead of at my house this year. So if anyone wants to go check it out, it's Baldwin City Public Library that I'm doing it at. So far we got pretty much all the lights set up. We're doing 4 more reefs, and then I just have to finish the controller. If you want, I can do a video on that controller. It's nothing that important, nothing really special, but it's a little bit of work behind it, but anyway, that's pretty much what I've been up to besides the cabin. I need to show you the previous progress I've gotten done on it, but I'll release a video probably towards the end of the compilation of all the photos I've taken with some background music and other stuff, because just a couple days ago when we were doing most of the framing, I took 19 photos, and then before that there's another like probably 50, not 50, like 15 of them, so expect that compilation. I got a new free video editing software for my laptop. It's called Lightworks. Works really well, actually. It's pretty professional. Up to 720p for the free version. It's pro version. I think you can go all the way up to 4K. If you don't have a good enough computer, like I've got an Intel Core i5, and because it actually renders the videos out. A lot of these cheaper ones just kind of splice the videos together, but this re-renders the full video out as one continuous video clip instead of splicing them together. So it will be very CPU intensive. Right now I can't really do much on my laptop because I'm encrypting 255 gig folder that has all my data on it, and I'm just encrypting it with like a 34 character long password, protect all my data, and so I can just keep it on an offsite location, like on an external SSD somewhere. But yeah, so that's what I've been up to. But this video is going to be about those guys and that. I did this kind of late in the evening because I was bored, and I was like, hey, I've been needing to do this video, and I've got nothing better to do right now, so let's do this. So this is the frame I built. It's surprisingly decent. I'm not the best woodworker, and I just kind of threw it together within an hour. So it's an L-shaped frame, 3 of them. I did basic, I think it falls under basic trigonometry, so it's basically I just use the tangent. I think what I used was tangent theta equals opposite over hypotenuse, and that will basically give you your general angle. I knew this angle up here had to be 51 degrees, and so basically going at that angle, so this would be theta, would be this angle. This one is a German symbol, I forget what you actually call it, but there's another calculation for that. But I think I actually did that angle first because I ended up using a calculator because I wanted to make sure I got the math right. So I think I went with that angle, which was it needs to be 51, so that angle needs to be a 39-degree angle, so I put in 39 degrees for that one, or you can put 51 for that one. And that will give you the total length of that. I knew the length of the panel, which was 36 inches. And then so I knew the width of it, so I knew how long I needed to make it. So the rest of it was simple math of the woodworking. But then this was, I knew that was 26. Geometry will tell you if that's 26, then if that's 26, then that side would have to be 2x, so that's, or 36, so it'd be half of that, so 18 inches would be that length. And then I went a couple inches over, so that's actually 20-inch long length. See how that works. And then this is 3 square roots of x, or x square roots of 3. I can't remember which way around that goes. Something with a 3 and square root in there. And then that was just the math I used to calculate all the angles and everything. I may make a base to go below this to do auto tracking, because it will go right out in that field. That will catch all of the morning sunlight because it starts there. This direction is south. Behind me is north. So that will catch all the morning sunlight. Then once it gets to around 1 o'clock, if I go right out in the middle, I can get up to 2 o'clock with decent sunlight. Then the trees cover and shadow it too much, so I may. There's a second field right over there that we have, that our neighbors use, but we still have a good section of it still that's our land. So I may make another frame out there to capture the evening, increase my efficiencies, increase my solar power, because what I'm wanting to do, I'm eventually going to want some more current. So these panels, it's 100 watt per panel. It's a 200 watt kit from HQST Solar. High Quality Solar Technologies, I think is their name. And it was like $260 on sale. It's only like 310, I think. It was like $260 on sale. And that gives you 2 solar panels. Two 20-foot sections of 10 gauge M4. One side of it's already got the M4 connectors, male and female. The panels have already got the connectors on there. There's an internal protection diode. I opened up the case. That's the... Ooh, I don't know if you'll be able to even see that. It's pretty bad. Let me see if I can increase the light a little bit. You can kind of read that. Pause it if you need to. But, so each of these panels is like an optimum voltage of like 20 volts, or max open circuit voltage is like 24. I can't even speak. The average voltage would be around 20 volts. So you get about 40 volts when normal sunlight's out. So then I have these put in series because that charge controller is right up to 50 volts. Let's see if we can balance the light out a little bit. There we go. A little better. So then I put them in series. So this is 200 watts at 40 volts, which means it's only like 4 amps. I don't know. It's not that many amps. I can't really do math. 5 amps, sorry. It's pretty stupidly simple math. 4 times 5 is 20. Add a 0 to the end, 200 watts. But it doesn't actually reach 200 watts. It's more, the average efficiency I get out of it is around 140 watts, normal sunlight, because if you don't know, when they make these, they actually have metal halide lamps or really bright LED lamps. They shine with a lot of lumens on top of these to peak the power. And I guess Madre is home. But so they basically bake this as much light as they can to see what the absolute maximum is, and that's how they get their numbers. And so you never actually see that number, so always over budget your system on solar. Like if you need a minimum of 300 watts, I say go with 500 watts just to give yourself some leeway, because you'll never actually experience that full wattage potential of solar panels. So they're put in series, ran through the 10 gauge cable, and I built this power rack. Nothing really that important. Let's see if I can, there we go, get the lighting down a little bit. So this is an old Cutler and Hammer disconnect, 30 amp rated, but you know, it's AC 30 amp, but you know, it's still a disconnect I got for free. Oh man, this thing has been bent. Hey, let's see if I can get her open. She's really bent. Yeah, this one's not gonna let me open it when it's, I forgot this one's still new enough where it has a safety latch on it, but turn that back on while it's there. So I don't really want to touch that. Still, I know it's dark out, but it can still be like 12 volts or something, and it's not enough to actually shock you, but I don't want to take precautions because I don't actually have a voltmeter across it. I could actually check on the meter right here, but so this is a 30 amp rated disconnect. I don't remember what the equivalent rating of DC rating is for those fuses, but I'm not going to need 30 amps. It's way over budget, so I think those fuses will work out just fine. So the 10 gauge comes in, comes out. This is like number 12 or something. This is 10 gauge, but really thick, so it's sun rated. So this may actually be 10 right here, or 12, I can't remember. It's only 20 amps, so you don't, and it's stranded, so chassis wiring scheme says 12 gauge is rated for 30 amps. NEC wiring scheme says stranded wire is only rated for 20 amps. It gets a little convoluted. So then the solar comes out into here, then out from here down into the stupidly big battery. This thing is 134 pounds. It's a cell tower backup battery. Yeah, literally. Don't lift this one with your back, otherwise you may have back problems within a few days if you keep on doing that. So this is only rated for maximum charging current of like 19 amps. It's 180 amp hour at an 8-hour rating, at a 1 hour rate, or at a 1 amp per hour, at a 1 amp hour rating. So I'm just drawing 1 amp to find out my hours. It's only rated for like 200 amp hours. So it comes out of there, and then, oh, I guess my phone's about dead. I'll wrap this up real quick. Comes out of there into, and it'll go from there to my 2000 watt inverter, which feeds the main panel. And then I have a 500 watt which will feed a small, just little, this 500 watt inverter will only feed something just like one outlet. This will feed the entire shed. So most things don't require smooth power. So I need to give plenty of wires. So I need to double this up because I need to have about 400 amp rating. I'm going to put a 500 amp A&L fuse right here. 1 second. All right, sorry about that. Because I have my phone set at the highest recording quality, the max time I can actually get is 10 minutes. So it was at like 9 minutes and 56 seconds. So it would have stopped me. So I figured I'd just say I'm going to take a break. So, so I'll basically go over a little bit more in depth, or I'll show you a little bit better. So yeah, solar comes in through the disconnect into the MPPT solar charge controller, maximum power point tracking solar charge controller, out into the battery. Then from the battery, it will go into two fuses. One, a 500 amp ANL fuse into the inverter, and then another one. Technically, I don't need to fuse it because I know it has a bunch of fuses on there, but safety reason, I would like to fuse it separately, but I may not actually fuse them at all because now that I always forget that they're still fused on there, but I prefer having a higher amperage rated fuse or an actual separate fuse. But so then eventually this will connect to this battery with another 4 35 amp hour sealed lead acid batteries that I bought for an e-bike project that never really worked because alternators are not good motors. So then I'm probably just going to put that in that battery, give me a total capacity of 340 amp hours, which means I need a minimum of 680 watts of solar to charge these batteries within a 6-hour time span. The way I did that math was you take 340 amp hours, 340 multiplied by 12. That gives you like 4,032 or something like that. And then you take that number, and then from that number, you need to divide that by your total sun hours that I'm going to get, which is roughly around 6 after just basically sitting out here and watching the sun. So then that gave me 680 watts of solar. I think that's what the actual number was. So I'm going to need like an 800 watt system to be able to get close to that, which means this charge controller eventually will be changed to like a 50 or 100 amp rated charge controller. So then everything will be through here. All the plugs and everything will be through here. But all the lighting in the shed is going to be 12 volt DC because I have a bunch of 12 volt, 7 or 9 watt rated light bulbs. I just think it's way too inefficient to step the voltage up, deal with the inefficiency of a modified sine wave inverter, and then just put it to a light bulb that will basically just step it down internally with its own circuit. So that's my plans with everything. So this is the main power board, 340 amp hours of capacity, which is completely overkill. So I could run this entire thing for probably a month at full tilt, or not at full tilt, with everything that's going to be in there. So all the lights on, everything, and then probably won't even be running anything off of that because I'm expecting my max draw to be around a couple hundred watts. I just had that laying around, and I wanted to match the batteries to that, and so in the future, matching the solar to the battery would be way easier, if you get what I mean by that. So yeah, I know this is kind of jumping all over the place, and I'm just concerned about my phone dying because it's at literally 2% right now. But let me show you this little control panel right now. But besides that, there's really not much. So on this control panel, you have select and enter. The enter key, if you hold it, will allow you to change your battery type. Let me see if I can focus on that a little bit better. There we go. So this is your select key up here. Your enter key's right here. So right now it's saying my battery's at 13 volts. See, it says it's nighttime because it knows the solar panels are connected, but it knows that there's not enough sunlight. So this charge controller does not have a load function on it, so that load light means nothing. So you press select, it gives you your voltage coming in, 6 volts. Yeah, it's really dark out now. Like, it's pretty dark. And then if you press select again, 0 watts or 0 amps coming in from the solar to the battery, or the battery's taking in 0 amps. The battery's at 93% because it's at 13 volts. Unfortunately, this is their cheaper charge controller, so Bluetooth is not enabled, and you don't have the nice things of Bluetooth. 13 volts is my battery voltage, 0 watts from the solar, and the amp hours it's used today is 6 amp hours, and 21 degrees Celsius internal, and then external sensor is not hooked up, so it says E0. So yeah, that is this setup that I'm using. This will be in the cabin. You will see it in the next, about the final episode when I'm actually putting it in the cabin. So anyways, my phone's literally about to die, so thank you guys for watching, and stay tuned for more cool things like this, and see you guys in the next episode.